Hello everyone and welcome to our MX Form 5. One of the chapter I think is very confused for you. Okay, this chapter actually is we have one term in our previous class for the Form 5 to the 4. We have one term we can use this for this chapter. So in this chapter, you learn about probability. This word, okay, you heard a bit about this, okay, in previous class or previous form, but today will be a little bit different and will be more difficult. But today I will let you to make you clear about today all the topics that you learned today. Okay, so first thing, what is random variable? Okay, you check for the first part of the textbook, you see random variable. Apa itu lah? Okay, if let's say 1, 2, 3, 4, 5, I read out as integer. I read about it. I just know about it. But today, if let's say 10 people here, who is wearing the glasses, I don't know, IDK, but I know about maybe 10 people can wear their eyeglasses. That is called as a random variable. Random variable is a variable that with the numeric values that can be determined from a random phenomenon. Okay, we have two types of the random variables. One is the discrete, one is continuous. Discrete is like the things that you can calculate, you can count one by one. For example, just now I said, okay, 10 people who has wear their glasses. I need to know. Okay, maybe got 1 people, got 2 people, 3, 4, 5, 6, 7, 8, 9, 10 people, or none of the people wearing their glasses. Can be like that. Okay, so this is for the discrete random variables. Now for continuous random variables, okay, all the things you do know. For example, from the class 5 almanac, okay, we see have 13 pelajar, 13 students. I need to know, okay, about the range for the height of the students for the class 5 almanac. So I use the range. Okay, I found that class 5 almanac has the range of 145 cm to 170 cm, okay, height for the students. This is the formula that I just said just now. Okay, we do know, but we know about the range. Okay, and for random variables, we have the formula. Okay, if x is a discrete random variable dengan nilai A1, A2, A3 sampai An, dan probabilities, okay, masing-masing ialah Px equals to A1, A2, A3 sampai An, and the large number of n. If you say R equals to 1, Px equals to Ri equals to 1, means, okay, the total probability is equals to 1. Okay, all the probability we add up together, you will get 1. So we can using this one to find one part of the probability. This is how the things going on. So we can using set notation, tree diagram, tabulation, graph to interpret the discrete random variable for the probability distribution. For example, this picture, this question. Can you see this question? Can you see this question below here? That is how we're going on. You're using tree diagram that you learn in Form 4 Chapter 9 Maths, and the tabulation and the table here. Okay, how we interpret the tree diagram. So first, okay, for example, today I want to know about, okay, how many times in 3 times I toss a fair coin. There is head and the tail. Okay, I do 3 toss. In the first toss, I get a head. In the second toss, I get a tail. Sorry, a head. In the third toss, I get, oh my god, I also get a head also. Means these 3 times, all I have is the head. So do as usual in Form 4 Chapter 9 that you know about it. You just kembangkan, expand, okay, until you get all the outcomes must be in 3. And next, when you already list out, you need to write x equals to r. R is means what? Okay, R equals to, that is, okay, all kernel head, all is kernel head. Okay, if one of the outcome is not the head, so we just deduct it. So R is equals to, okay, the outcome that is fulfill the condition that I just now I say, okay, the probability to get a head in these 3 toss. So now go already settle for x equals to r, so you can calculate the probability for x equals to r. Okay, just, okay, multiply all the things in the first outcome, all the 3 outcomes in the first, second, third until the last. Then you can conclude all the data here by using the tabulation data, and you can draw the table. Just now I said, okay, just now I said I do the experiment 3 times, but today got one uncle that called Bernoulli. Okay, he tell me about it. He said, okay, the Bernoulli trial stated that, okay, there is only 2 possible outcomes, namely success and failure. The chances of success always same in every trial. Okay, if the probability of the success was given by p, then the probability of failure is given by 1 minus p. Okay, and the discrete random variable x 0 1 means 0 is failure, 1 is success. So I can make it 3 toss, but Bernoulli trial say that I just using 3 toss to determine the probability, that is not useful. That is wrong. You need to do the experiment many times, repeating many times, so you can get the appropriate, the accurate the reading, accurate answer for the probability. Today we're using the binomial, we're using for the Bernoulli trial to determine the binomial diffusion, probability of being event for a binomial diffusion. Remember, here we always in always in the discrete random variable, not in continuous random variable. And a binary random variable is a number of success R from n similar Bernoulli trial in a binomial experiment. The probability distribution of a binomial random variable is known as a binomial distribution. Okay, this is the explanation, and we can represent the binomial distribution using the formula NCR PRQN minus R. Okay, so the NCR is actually came from your from 5 chapter 4. Okay, MX. Okay, it means in n number of trials, I choose the 3 number that is successful, the successful trials, and the P is the probability of success. The R, I already said that the R is a number of successful trials, and the Q is the probability of failure. Okay, and N minus R. So R must equal to 1, 2, 3 until the last one, and the whole thing will equal to 1. And we can represent this as X. Okay, the sign. Okay, B is the binomial, and then NP. That is the thing going on. So P plus Q equals to 1. So I just said that. Okay, the whole probability equals to 1. P equals to 1 minus Q. Q equals to 1 minus P. And we can using the binomial distribution to determine the mean, variance, standard deviation. Okay, we can using the mean, variance, and the standard deviation to determine, okay, the binomial distribution. Okay, alternatively, okay, so first thing, okay, I give example. Okay, for example, the probability that it will rain in a particular day is 3/5. Now I want you to find the probability that in a particular week it will rain for exactly 4 days. Okay, or okay, I want to calculate for more than 5 days. So I will calculate like this. I will write the representation X, the sign B, and I will put 7. 7 is the what? Week. So I say that, okay, week means the number of trials is 7. P is the probability to success. So if your rate is 3/5, so it means the probability that I fail is 4/5. I minus for it. So I say Px equals to 4 equals to, in 7 days, got 4 times that the experiment is successful, and probability that success power with the 4 days are X, we have rain, and 3 days didn't rain. So the probability will become 0.290304. Okay, and you need to write the answer in the full. You need to write the answer fully. You cannot make it simple. Must write the answer whole, means completely. Okay, if about Px larger than 5, we can do like this. More than 5 days means, okay, I don't want the first, second, third, fourth, means after the day 5, another 2 days rain. Okay, after the 5 days, okay, just have 6 day rain or 7 days rain. So I calculating all the things, I will get 0.1586304. So we have about 0.1 chance to rain. It's very small. So we're using the probability distribution binomial distribution to find the mean, the variance. Okay, and that's all for the binomial distribution. Now we will move for normal distribution, the most hardest. Okay, so for the normal distribution, it's a probability function of the continuous random variable, means already in continuous. And okay, so there is a graph here, and the graph, the middle here, mean equals to median equals to mode. Okay, and the graph is symmetrical about analysis and the center of the normal distribution. Okay, and in this whole graph, you equal to 1. And we can represent the normal distribution like this: x, okay, the sign x, and mean and comma and the variance. So we are using the mean, variance, standard deviation to change it to normal distribution. Okay, normal distribution usually is used for the continuous random variable. Okay, untuk bahasa Melayu di sini. Okay, and the graph can be changed when mean and the standard deviation change. If the mean value change, mean value higher, more right the position of the graph. If the standard deviation, means the deviation, okay, the value is more higher, the larger the height of the graph. But you need to know, this one must be in the per-mala, constant. In mean, here our standard deviation is always constant, but here our mean will stay constant. Only the standard deviation will move. And this is for the normal distribution. Next thing, we need to standardize our normal distribution by using this formula. Okay, just now we learned about x, b, and p, and you move for the this one, xn, and then the mean, and then the variance. But now we change it to become z-score. Okay, standard normal distribution. A standard normal distribution defined as a normal distribution whose mean and standard deviation are 0 and 1 respectively. So it means the 0 always mean, 1 is the standard deviation. So wait, question asking you, okay, 0 is a mean, standard deviation is what? 1, center, and we can calculate the z-score using this formula, and this will how is the thing going on. Okay, when this is for the normal distribution like this, our mean is to be here, and when we standardize, we will move the graph to here to make it like this. And before that, you need to know the example 14 in your textbook. Okay, your textbook, example 14. Okay, understand the thing first, then you can move for this part, because this is a very means the difficult thing lah. Okay, and Next thing is about this one. Okay, how do we find the probability, okay, when given z-score? We're using z-score to determine the probability, and remember to always sketch a graph, okay, here, to let you understand about it. And actually we're using the table that I think in Form 4 I already tell you about this table, okay, in your formula paper. Okay, so now I will teach you how to use this table. So first thing, in example I said, what is the amount of what's the probability for the z larger than 0.235? Okay, I determine the 0.235 using the table here. Okay, first I will move for this one. I will move for this one, and later on I will see here. Okay, I will see. Okay, the first value I will find is here. Second value, this is for the second value. The third value, how to determine? Third value is here, 5. What we do? Using this value, subtract with the value here. The 19 actually is 0.0019. It's a 4 decimal places. Okay, it's a 4 decimal places. We can, using this, to find the accurate probability. That is the answer. We also can use this, okay, use this to find back the answer. But now teacher, I want to use this one. I give you something. I use this one now, more better lah. Using this one, okay, 0.4071. Okay, I see. Which number is more closer? These two. Okay, these two is more closer. I don't see this. See, I don't see. I see the closer. Okay, I see. No. Okay, no numbers like this. But here got two number is closer than this number. So I choose the larger one. I don't choose the lesser one, because I can using this to subtract with this, so I can get the remaining number here. Here I can get the 19 here. Sometimes you didn't get the answer accurate, so I can depend on which number is more accurate, is more suitable to use, so I can compare it, I can adjust it. If I get the answer is 19, so I put this one here. So it is 0.235. Same thing, right? That is how we find the probability, or alternatively. And z-score must be in positive value. If let's say I see this one negative value, okay, so I will make it in other side, because here and here is same thing, but the answer cannot be in negative, must be in positive. So I make it here, and I using my table to find answer. This is like this lah. And we also can using the mean standard deviation to finding what? To finding the original value. Okay, given px larger than m equals to 0.2266. Okay, and remember this is x. We need to standardize the probability distribution. Okay, z larger than m minus 14. okay, divide 12 because we have the value here. And by looking at the table, we can find the answer and find our final answer here. And usually the question you're asking like this one, okay, you need to identify the question given, okay. Sometimes you're asking to find x something, sometimes you find for probability, sometimes you find for mean, standard deviation, variance, percentage, number of or mass score. Later on, first find z-score. If you see got x1, okay, find for z-score. If got z-score, you asking to find x, so you can do the balikan in vice versa. Okay, later on, okay, you draw the graph, right? Draw the graph like this. The graph, I can find for the probability. From the probability, you can find an unknown value or find a new value. If question given a new value, to find the new probability. That is what I look like, what I see the question, okay, the pattern of the question. But in SPM, I think it's not easy like this. They will be more harder. But if you have the basic of this idea, I think you can do the easy part. The hard part, I think, if not too many marks, you can just let it kosong. But I suggest you to do that. Try your best because sometimes you have marks on the steps, okay, the working steps. Okay, so I think for the normal distribution, we end from here. So we conclude all we learned today. Okay, for probability distribution, we learned about discrete and continuous random variable. And for discrete, we can calculate, we can count. So all the things, the total is 1. For continuous, you can't calculate, we can't count, but you can know about the range can be more larger. And the whole thing must be 1. Okay, and for probability distribution for the discrete random variable, we can interpret by tree diagram, table, graph. For continuous, only the graph like this only. Okay, and for the discrete, we're using for binomial, continuous, normal, and we can use the binomial to determine mean, variance, standard deviation. Using normal distribution, we standardize it, become a standard normal distribution or z-score, and we can use all the things we learned today, okay, to answer the question. That's all from today, and we will see in the next chapter from 5 to 6 trigonometry functions. Goodbye.